Hi guys, welcome back to another video. So as you know, this is our concept builder series. The topic we are going to cover today is mixture problems. Now a lot of students find this topic little difficult. Those who understand the butterfly method, they are quite happy with it, but most of us find it very difficult to implement and apply. So in this video, I'm going to teach you another super simple method. Right, if you've seen the previous videos, you know we make simple tables. In this also we'll learn a very simple table method to solve most of your questions. Okay, so without further ado, let's start. Okay, so when we talk about mixture problems, as I said, right, what we are going to learn in this video is what is mixture problems or what comprises of mixture problems. Right, we'll learn the traditional, butterfly method. Right, and we'll learn a simple to apply, right, a very simple to apply table method. Okay, so let's start with mixtures. Right, what are mixtures? See, mixtures, as the name suggests, is simple. It's a mix of two or more things. Okay, so you have, say, element A, okay, that you mix with element B, right, to give a mixture. Okay, now, but why stop there, right? Why just have only two elements? Okay, you can have three elements also. You can mix three elements. You can mix four elements. That simply depends on us. How many elements I want, right? So mixture is simply amalgamation, okay, or addition of two or more things. Okay. Apart from that, now if you think about maths in general, see, addition and subtraction follow the same principle. Okay, so again, it need not be addition only. You can have subtraction as well. Okay, if you want, you can have subtraction as well. That is, I already have something and I take something out of it. Okay, and then I add something else into it. So mixture is simply, okay, we have one element, could be a mixture, could be compound, could be anything, alloy, right, whatever, and then we add or subtract other elements to it. Okay, and we end up with a final resultant mixture. Okay, I hope that makes sense. Okay, so in mixture, again, we just add or subtract multiple elements or mixtures to get a final resultant. Okay, now question comes, how do we solve it, right? So as I said, we'll discuss the traditional method, which is your butterfly method. Okay, now see, the reason some of us find this method difficult is because we all memorize what to write where, but we never focus on why is it coming, how is it coming, what is the logic behind it. Okay, so if you understand the logic behind it, maybe some of you find this method also quite easy to apply. Okay, so see, the concept of butterfly method is, let's take an example. Say you have a group of friends. Okay, these are, say, 100 people. Okay, you have a group of friends which are, say, 100 people. Okay, you have another group, say a smaller group, which has only 10 people. Okay, so we have a group which is 100 people, another group which is 10 people. Now these two groups decide that, okay, we need to combine and become a bigger group with 110 people in it. Okay, that can happen. Think of it like company. There is a very big company with 100 employees, another small company with 10 employees. This company and that company decide that they will partner. Okay, right? So then we'll have 110 employees in that company. Right, now when this happens, okay, think logically, what happens, right? If there is a decision to be made, okay, with respect to, say, policy or anything, they are at one point, okay, these people are at another point. Okay, all right, now say when we talk about like meeting, right, so they won't meet at the middle, right? Okay, they won't meet at the middle. It's very idealistic of us to think that, oh, let's meet in the middle. These are 100 people. Okay, they will say no. we are majority, listen to us. So they may compromise, okay, which like most of us at certain point might do, right? They may compromise, but they won't compromise a lot, right? They may compromise, but they won't compromise a lot, right? They will only compromise a little. These are fewer people. So what will they have to do to reach an equilibrium, right? They will have to compromise a lot more, okay? And the place where the quantity is more, to reach the equilibrium, they'll compromise less, okay? The point being that if there are two companies, or say there are two products, okay, one has say 100 kgs, the other has 10 kgs, okay, one product you're selling say 100 kgs, other product you are selling say 10 kgs, and when we say okay, let me combine this and find what is my net cost price, so the product that has 100 kgs will weigh more, right? If you know weighted average, you will say yes, the weight of the product one with 100 kgs is more, right? So since the weight is more, they'll compromise less, or the equilibrium will shift towards this people, okay, and shift away from fewer people, okay. So based on this concept, okay, we have, what do we say, the butterfly method, okay. Based on this concept, we have the butterfly method, right? Okay, so what does butterfly method say? That okay, see, this is your average of the first element, okay, this is the average of first element, this is the average of the second element. Now all of us know, if one number has, or say one product has an average of say 30, the other has an average of 20, the overall average or the compromise will come somewhere here in between the two, right? Think of it, right? Like you are planning to rent a house, you go with another some value, the other person comes with another value, and what do? You compromise somewhere in the middle, right? So similarly, the average of the mixture will be between the two values, okay, not exactly in between, somewhere between the two, okay. So then, right, we make the crisscross sign, and what do? We subtract. So again, this A mixture will be greater than 1 and smaller than the other one, okay, because it will lie between the two. So we cross multiply, or we make a cross and we subtract, okay. I'm just writing a modulus sign here because it has to be positive, right? Right now I don't know which one is greater, which one is smaller. A mix will be greater than one, smaller than the other. Which one I don't know, that is why I have put modulus, okay. So this difference, right, this difference that we have written, this difference is basically telling you the compromise one is making, okay. This difference is basically telling us the compromise, okay, that the the other person is making, okay. The compromise made by A2 is A2 minus A mix, the compromise made by A1 is A mix minus A1, or A1 minus A mix, okay. And if you see the previous concept, or the basic point of this concept is the one whose quantity is more will compromise less. So basically you compromise, or basically you move, okay, according to your quantity or according to your weight. So if you have more weight, you move less, if you have less weight, you move more, okay. So then what happens, this ratio, the compromise ratio, is your quantity ratio, okay. So the logic comes that, see, if my weight is more, I'll make the other person compromise more. If my weight is less, I'll make the other person compromise less. How much more, how much less, depends on the quantity. So the compromise ratio is same as the quantity ratio, okay. The compromise that we make the other person do, not the compromise we do, the compromise we make the other person do, okay. So this is where the formula comes from. Okay, now you just write this in formula. So we get A2 minus A mix by modulus A mix minus A1. Ratio is quantity ratio. Okay, so this is what the butterfly method is. This is where this is what the logic of that method is. Okay, remember, it is if my weight is more, if my quantity is more, if I have more people in my team, okay, then I'll make the other person compromise more. I will compromise less. Okay, if my strength is fewer, okay, then what will happen? I'll have to compromise more. Okay, does that make sense? Right? So, right, using this, right, this is what the butterfly method is. This is how you can understand it. Okay, now let's solve one example to see how this method works. So I hope you have read the question. So see, what do we have? A bakery combines two syrups. Syrup X has 15% cocoa. So this will basically become my average. Average here will become what is the average percentage of cocoa, okay, in your syrup. Syrup Y has 35%. 20 liters of syrup X is used. Syrup Y need to find. Mixture average is 30%. Okay, mixture average is 30%. Okay, so let's make our butterfly. We have element X here, or syrup X here, syrup Y here. Average of X 15%, average of Y 35%. Now as I told you, the mixture average always comes between the two. So if you see, that is 30%. Okay, now if you draw your crosses, okay, if you draw your crosses, this is 35 minus 30, which is 5%. This is 30 minus 15, which is 15%. Okay, 35 minus 15, which is 15%. Okay, now again, from the method we know this ratio, the compromise ratio, the difference ratio is quantity ratio. But which quantity ratio? So since we have X here, quantity of X, Y here, so quantity of Y. Okay, so this ratio is quantity ratio. So if we solve that, 5% over 15% is quantity of X, which I know from the question is 20 liters over quantity of Y. If you simplify this, quantity of Y becomes 60 liters. Okay, if you simplify this, cross multiply, we get quantity of Y as 60 liters. Again, bringing it back to our logic to understand this method, see, Y had 35%, X had 15%. When they mixed, why did the total come to 30%? Why is the total closer to Y? That means quantity of Y has to be more. How much more? Right? So that depends on, as I said, the quantity ratio. So we found the difference. The difference ratio, if you see, is 1:3. Okay, if you simplify it, the difference ratio is 1:3. So the quantity ratio also has to be 1:3. Okay, Y is making X move 3 times. See, Y is moving 5 steps. Okay, Y is moving 5% or 5 steps. It is making X move 15% or 15 steps. So it is making X move 3 times as much. Why is that? Because its quantity has to be 3 times as much. Okay, so that is why quantity ratio is 1:3. We get quantity of Y as 60 liters. Okay, so I hope you understand the logic of using butterfly method now. Okay. However, right, again, as I said, a lot of people find butterfly method little confusing to apply, especially in the difficult questions. Okay, so this is where our table method will come into play. It will help you solve all types of questions very easily. You can make the table very easily. Okay, it's very easy to understand, it's very easy to apply. Okay, and you can solve the question very quickly. Okay, so let's look at that. Right. So next is our table method. Okay, now how does the table work? Obviously you have to make a table. Let's start with the columns. Okay, you simply write down what is mixed with what to give you what. So for example, A is mixed with B to give me the mixture. Another important point that we'll see in one of the questions later on. Okay, the butterfly method works only when there are two elements, because you can only make two crosses. Okay, whereas this will work when you mix 2, 3, 4, however many elements. Okay, again, need not be plus always, you can have minus also. From A I can remove a certain portion and then also get a mixture, a diluted mixture maybe, or a more concentrated mixture maybe, right? So what you do, again, you write what is mixed with what and what to give you what. Okay, now this A can be a simple element, say syrup X, or A can be a mixture also. So you can have mixture A is mixed with mixture B is mixed with mixture C to give me a fourth mixture. Okay, so you just have to read the question and simply understand what is it that they are mixing. Okay, so this is my column. Okay, now my first row is always quantity. Okay, my first row is always quantity. Okay, so quantity of what? Quantity of this whole A. If it is mixture, then quantity of the entire mixture. Okay, quantity of B, quantity of C. Now let's take a simple logic. See, if I mix three items, one has 10 kgs, the other is 5 kgs, and the final one is 3 kgs, and I mix them up, right? What is the total mixture that I get? Okay, so I get 10 plus 5 plus 3, 18 kgs of mixture, right? What happens? The net quantity adds up. Okay, if there is a subtraction, it will subtract. So the net quantity, the quantity of the mixture, is QA plus minus QB plus minus QC. Okay, this is A, this is B, this is C, this is mixture. So net quantity is QA plus minus. Plus minus will depend on the question, right? Whether you are adding or subtracting. So QA plus minus QB plus minus QC. Okay. So net quantity, right? This is where we start, right? Net quantity is again QA plus minus QB plus minus QC, depending on, plus minus depends on the question. And again, as I said, if you have two elements, then only two elements. 3, 3, 4, 4. You can have however many elements you want. Okay, it's a logical method, so it will work all the time. Then we write P. Okay, then we write P, right? Okay, this P is actually a factor. Okay, a factor for which you are going to make the equation. Okay, right, a factor for which you are going to make the equation. Now this P factor, right, it can be average, it can be percentage, it can be concentration, it can be proportion, right, it can be cost price, selling price. Okay, just keep it uniform. It can be anything, just keep it uniform. So the same thing that you do in your butterfly method, right? You take average. Same thing is this P, right? You pick a factor that, okay, I'm going to make equation for, say, the example percentage of cocoa, or I'm going to make the equation for average weight or average height. Whatever it is, just pick one variable. Okay, pick one factor for which you are planning to make the equation, right? Then we write the value of that factor in A, right? Similarly, we write PB, PC, and P of mixture. Okay, and then the last column. Now this is where your entire question gets solved. Okay, this is where your entire question gets solved. Okay, and this equation is the same equation always. Okay, and that is simply PA into QA plus minus, depends on the question, PB into QB plus minus PC into QC is equal to Pmix into QA plus minus QB plus minus QC. Okay, so this is a single equation that you will make always. No matter what the question, you will end up with making this equation. No matter how many variables there are, always end up making this equation. Okay, so all you have to do is write down the variables, what is being added or mixed with what to give you the mixture. Write down the quantity, net quantity based on this quantity. Decide a factor. Read the question and you decide the factor. That okay, I want to make my equation for this factor, this variable, this percentage, this concentration, cost price, selling price, whatever it is. Pick one and keep it uniform. The last line, the last row is where you solve the question. Okay, and people who are aiming to get 90 percentile or 99 percentile rather, with enough practice, you should be directly writing this equation. Okay, we don't write the table. With enough practice, again I'm saying with enough practice, you directly write this last row, you directly write this final equation. Okay, I hope you understand this. Let me show you this in the same example that we did just now. Alright, so you must have read the question now. It's the same question again. Okay, so let's read and understand. First, what is mixed with what? So I know syrup X is mixed with syrup Y to give me the mixture. So I write syrup X added to syrup Y gives me the mixture. Okay, syrup X gets added to syrup Y to give me the mixture. Now, as I told you, what do we do always? We think about quantity. Okay, don't worry about the entire or the remaining question. Go step by step. Focus on the quantity. What is the quantity of syrup X? That's 20 liters. Mixed with syrup Y, I don't know, QY. Mixture quantity will become 20 plus QY, because when the two things add up, the quantity adds up. Now, focus on the factor. Here, I'll try to make the equation for percentage of cocoa. Percentage of cocoa, right? If you see, this is what I took as average in my butterfly method. Same thing. What is the percentage of cocoa in X? 15%. Y? 35%. Mixture? 30%. Right? Both my rows are done. This is where magic happens. Just write down the final equation. 15% times 20 plus, the plus borrows from here, 35% times QY is equal to 30% times 20 plus QY. Okay, percentage cancels out everywhere. So we have 15 into 20, that's 300 plus 35 QY is equal to 600 plus 30 QY. 5 QY is 300, QY is 60. Right? So again, QY is 60. Okay, right? Again, you might think that, see, this is taking time, I have to write so much. Give it some time, practice it a little bit. You will find all the questions super easy. Okay, you don't have to think, you will never get confused. You just simply follow the steps. Quantity, what is it? What factor do I want to make my equation for that? And as I said, with enough practice, we directly make this equation. With enough practice, we directly make this equation. Another advantage, when you have multiple variables, more than two, this will still work. And it again, you will have only one equation. Okay, so I hope you understand how to apply the table. Alright, I hope you have read the next question. So again, right, once you have read, let's just focus on making our table. So let's figure out what is mixed with what to give us what. So see, we have an original pesticide solution that is mixed with pure active ingredient to give us the final solution. So what do I write? Original pesticide solution mixed with pure active ingredient gives me final pesticide solution. Okay, now I focus on the quantity. Right, next step is to focus on the quantity. What is the quantity of original solution? I know that's 50 liters. What is the quantity of pure active ingredient? This is what they want me to find. Quantity of the final mixture, 50 plus QY. Okay, 50 plus QY. Once that is done, now think, what variable do I make the equation for? What should be my factor? So as we can see the percentages, we see it's percentage of active ingredient. So that's percentage of active ingredient. So what is my active ingredient in original solution? That's 10%. What is my active ingredient percentage in pure active ingredient? They say pure. Pure means it has to be complete 100%. And in my final, it is 20%. Now you see, table is complete. Let's solve the questions. So 50 times 10% plus QY times 100% is equal to 50 plus QY times 20%. The percentages cancel out. So we have 500 plus 100 QY is equal to 1000 plus 20 QY. 80 QY is 500. QY is 500 over 80. If you simplify that, that's 6.25. Okay, if you just simplify it, cancel it and simplify, that's 6.25. 0 cancels, 8 and 50 cancels, 25 by 4, which is 6.25. Okay. Alright. So now if you have read this question, see, this is where you will realize that why the table method is easy and why it works everywhere. The butterfly method will take longer now. Okay, but your table method will take the same number of steps. See, we are adding 3 types of diesel now. Okay, so I have diesel A mixed with diesel B mixed with diesel C to give me the final mixture. Okay, so again you just add another element to your table, that's all. Okay, now focus on the quantity. What is the quantity of diesel A? So if you see here, we know 3 times as much diesel A as diesel B and twice as much diesel C as diesel B. So if quantity of diesel B is X, quantity of diesel A is 3 times, so 3x. Quantity of diesel C is 2 times, so that is 2x. Net quantity, addition of all, 3x plus x plus 2x, that is 6x. Then we make the equation for a factor. If you look at the question, you will realize percentage of biofuel is our factor. So we have the factor as percentage of biofuel. For A, it is 15%. For B, 35%. For C, 50%. For mixture, they are asking. So P mix is what they are asking. Again, you see the table is complete. Let's make our equation. 3x times 15% plus x times 35% plus 2x times 50% is equal to 6x times P mix. Okay, you can take percentage common. Okay, we are taking percentage common. I have 3x times 15, that's 45x. X times 35, that's 35x. 2x times 50, that's 100x, is equal to 6x times P mix. Okay, if I add this up, that's 180x over 6x percent is P mix. Simplify this, that is 30%. Okay, so this is where you will realize that, see, the table method can be applied everywhere. Okay, if you have 3 variables, write them down. If you have 2, write 2 down. If you have 4, write 4 down. Okay, I hope you understand this. Alright, so if you have read the next question, we are again back to 2 variables. Okay, solution P, right? Solution P is mixed with solution Q to give us a mixture, right? So we write P plus Q gives us the mixture. Okay, let's focus on the quantity. Quantity is not given. They have asked us the ratio, right? In what ratio they should be mixed. So quantity ratio is what is asked. Okay, so this is quantity of P, this is quantity of Q. Mixture quantity is QP plus QQ. Okay, the mixture quantity always adds up. Again, let's focus on the factor. Factor, if you see, is clearly percentage of acid, right? If you see here, we have 30% acid, we have 70% acid, we have 40% acid. So percentage of acid, that's 30%, that is 70%, that is 40%. Again, table complete, write down the equation. QP times 30% plus QQ times 70% is QP plus QQ times 40%. Percentage again cancels out. 30 QP 70 QQ is equal to 40 QP plus 40 QQ. Get the same variables on same side. 10 QP is 30 QQ. QP by QQ is 30 by 10. That's 3 by 1. Okay. Again, they had not given the quantity. No problem. Take them as variables. Complete your table. It's again the same equation that you need to make to solve. Alright, if you have read this is again an interesting question, but again falls right into our table. Right. So see, you have the operational expenses increased by 4.25%. These expenses are made up of employee salaries and infrastructure costs. So again, I can write employee salary plus infrastructure cost is equal to operational expenses. Okay, again I can write employee salary plus infrastructure cost is equal to operational expenses. Again, we focus on the quantity. Now, if you see, the question says what percent of total expenses was allocated to infrastructure. Okay, now they have asked quantity but in terms of percentage. Okay, if you read here again, they have asked quantity, right? They are asking total expenses percentage allocated to infrastructure. Okay, so they have asked quantity of infrastructure but with respect to percentage. So let's say infrastructure is X%. Now total expenses I know are 100% because everything is 100% in total. So total expenses are 100%. If total is 100, this is X. That means employee salary are 100 minus X%. Okay, think about it. If infrastructure comes to 10% of the total cost, that means employee salaries were 90% of the total cost, right? So similarly, X%, 100%, this means this is 100 minus X%. Again, let's look at the factor for which we make the equation. So that's percentage increase. Okay, that is percentage increase. Again, as I told you, you can make the equation for whatever you want. You just have to keep the factor same for all. Okay, so we are making the equation for percentage increase. The percentage increase is overall 4.25. Employee salary is 3.8 and infrastructure is 5.6. Right, table complete. Let's make the equation and solve. 3.8% into 100 minus x percent plus 5.6% into x percent is equal to 4.25% into 100%. Again, the double percentages cancel out. So we just have 3.8 into 100 minus x plus 5.6x is equal to 4.25 into 100. Okay, what did I do? These percentages, double percentages everywhere, I cancelled them out. Okay, now we have simple equation. 380 minus 3.8x plus 5.6x is equal to 425. Okay, we get 1.8x is equal to 45. X is equal to 45 over 1.8. If you simplify, that will be 25%. Okay, again you can do decimal goes 450 by 18, cancel by 9, 50 over 2, that is 25%. Okay. I hope you have read the next question. Again, it's a different type. We have ratios given. Doesn't matter. We still make our table. Okay, we still make our table and solve the question. To make your table, first, what should be mixed with what? So if you see, there are two types of alloys that are mixed. So alloy A is mixed with alloy B to give you the final mixture. So what do we write here? We write alloy A mixed with alloy B to give us the final mixture. Okay, alloy A is mixed with alloy B to give us the final mixture. See, alloy A is made up of gold and silver. So if you see the question, you are not adding gold and silver and making alloy A. That is already made. What you are doing is, you are mixing this alloy with another alloy to give the final mixture. Okay, you are mixing this alloy with another alloy to get the final mixture. Again, step 2, focus on the quantity. Okay, we have 30 kg of final alloy. So final alloy is 30 kg. So final mixture is 30 kg. Okay. Alloy A rate, I don't know. That is what they are asking. Let that be x. This total is 30. A is x. So B will be 30 minus x. Okay. Now it is on us. Okay. Now it is on us. What do we want to make the equation for? As I said, pick a factor. So do you want to make equation for gold or silver? Okay, you pick one. You don't have to pick both. You don't have to make equation for both. You simply pick one. Okay, either pick, let's say for example, we make the equation for gold. Okay, I'm picking concentration of gold or proportion of gold. So if you look at gold, in the final mixture, the ratio is 3:7. That means there are 3 parts gold, 7 parts silver. So finally, gold is how much? 3/10 of the total. Okay, how do I get 3/10? Okay, how much gold is there in alloy A? So again, the ratio is 2/5, 2:5. So gold is 2/7. Similarly, gold in alloy B, 5:9. So 5/40. Okay, 5/40. Remember, you pick a common factor. So I have picked gold. Okay, the proportion of gold. Gold is to silver was 3:7. Gold is how much? 3/10 of the total. Right? Now again, table complete. Make the equation. So you have 2x by 7, 2 by 7 times x plus 5/14 times 30 minus x is equal to 3/10 times 30. Okay, let's take LCM here. 4x plus 150 minus 5x is equal to 9. Okay, if we solve this, 150 minus x is equal to 126, x is equal to 24. Okay, x is equal to 24. Okay, now say instead of gold, say for a minute, instead of gold, if you would have taken silver, then what happens? Okay, so instead of gold, if I take silver, this 2 by 7, I write 5 by 7 because silver is 5 by 7 in A. Instead of 5 by 14, I write 9 by 14 because here silver is 9 by 14. Instead of 3 by 10, I will write 7 by 10. Okay, so instead of gold, if you take silver, these values change. Again, table is complete. Again, if you solve the equation, you have 5x by 7, 5 by 7 times x plus 9 by 14 times 30 minus x is equal to 7 by 10 times 30. Okay, now again if you take LCM, it's the same number of steps, right? It's just the variable, like the values change. 10x plus 270 minus 9x is equal to 21. 270 plus x is equal to 294. If you solve, x is again 24. Okay, so honestly, it does not matter whether you pick silver or gold. As I said, pick one factor and keep that factor uniform. Okay, pick one factor and keep that factor uniform. Now, this is again another question where a lot of students make mistakes or find little difficulty in. Okay, what is happening? Water is getting evaporated. So we think, can we apply mixtures or not? How will this work? Right? Can we think of a different way? Again, as I said, mixture does not only mean addition. See, in math, addition, subtraction are the same. Okay, so we apply the same table, but instead of plus, we just write minus. Okay, again, if you have read it, what do we have? So we have original watermelon, water evaporates, and we have final watermelon, right? So what do we write? We write original watermelon, water evaporates means water is subtracted to give me final watermelon. Okay, the big difference comes here. Okay, water is evaporating, so it becomes minus. Okay, rest of your table remains the same. Quantity, what is the quantity of original watermelon? That's 200 pounds. Okay, how much water evaporated? I don't know. So x. So final watermelon will become 200 minus x. See, till now, because we were adding things, there was a plus sign. Here, because water is evaporating, it's going out, reducing the quantity. 200 minus x. This sign carries over. Again, what do you want to make the equation for? Think of a factor. So if I see, I have percentage of water, right? I have percentage of water. So let me make the equation for percentage of water. Original watermelon, percentage of water was 96%. The water that is evaporating is pure water, right? We have done a question before where you had a pure active ingredient. The water evaporating here is again pure water. So that's 100% water. And final watermelon has 92% water. Again, table complete. Let's make the equation. 96% times 200 minus, see again this minus is super important, 100% times x is equal to 92% times 200 minus x. Again the percentage cancels out, that's 96 times 200, that's 190, 200 minus 100x is equal to 180, 400 minus 92x. 800 is equal to 8x, x is equal to 100. Okay, that means 100 liters of water was evaporated. Now read the question carefully. Okay, new weight of the watermelon. So they are not asking x. Okay, this x came out to be 100, but that's not the question. The question is new weight of the watermelon. In this instance, 200 minus x also comes 200, but remember they asked us 200 minus x. Okay, I hope you understand this. Okay, now if you look at a similarity to previous question where we took gold, right? A smarter way, okay, to solve this question slightly more quickly. See, instead of taking percentage of water, take percentage of watermelon pulp. See, watermelon has what? It has water and pulp, right? The thing that you eat, right? Watermelon has water and pulp. Okay, so instead of making the equation for percentage of water, because see these values are so high, calculation will take time. Instead, let's make the equation for percentage of pulp. Original watermelon has 96% water. That means it has 4% pulp. The water that is evaporating is pure water. Pulp does not evaporate. So that has 0% pulp. Final watermelon has 92% water. That means 8% pulp. So if you make the equation now, okay, that's 4% into 200 plus 0% into 100 is equal to 8% into 200 minus x. Okay, 0 into 100 becomes 0, percent cancels out. I have 4 into 200, that's 800 is equal to 1600 minus 8x. Again 8x is 800, x is 100. Okay, alright, this is a very interesting question. If you see, we have selling price, we have loss percentage, we have cost price, we are beans mixing in some ratios, right? Lot of different variables. Again, do not worry, just focus on making your table. Okay, first things first, what are we mixing? Two types of coffee blends, right? So we are mixing coffee blend A with B to give us the mixture. Okay, we are mixing coffee blend A with B to give us the mixture. Again, then let's focus on quantity. Okay, so if you read here, they are mixed in the ratio 2:3. So quantity of A is 2x, B becomes 3x, total quantity becomes 5x. Okay, quantity of A is 2x, B is 3x, total quantity becomes of the blend 5x. Now, as I told you many times before, this is the important part. Pick a factor and keep it uniform. So for example, I'm picking the factor as cost price. Okay, so I need cost price everywhere. What is cost price of A? We don't know. That is what is asked. So let that be P. Cost price of B, that is 28. Cost price of mixture. Okay, don't just write 27. This 27 is the selling price. Okay, this 27 is the selling price. Okay, we know selling price, we know loss percentage. From that we will derive the cost price. Okay, so we know selling price, since there is a 10% loss, is 90% of cost price. Okay, if you want to understand this, you can watch our profit loss video. Okay, you will get that point there. Selling price, because there is a 10% loss, so selling price is 10% lower than cost price. So selling price is 90% of cost price. Okay, if we solve that, selling price, okay, we know is 27, sorry, is 90% of cost price. If we simplify this, we get cost price as 30. Okay, if we simplify this, 0 0 cancel, 9 1s are 9 3s are 10 goes in cross multiplication, 30, right? So remember, you can't write 27 here, you have to write the cost price, which is 30. Now the table is complete, so let's make the equation. 2x times P plus 3x times 28 is equal to 5x times 30. If you see, x cancels out, 2P plus 84 is 150. 2P is 66, P is 33, right? If you solve, P is 33. So remember, you can still make your table, keep the factor same. Whatever is not given, convert that into your factor. We had taken the factor as cost price, so we need to write cost price everywhere. Again, if you see another interesting question, we have certain things which are being removed, they are being replaced, right? Again, do not worry, the table will work for you. Okay, so we have a container which already has juice mixture. Okay, so the juice mixture is already present. Okay, then what happens? A portion of this is removed. How much is removed? I don't know, but some amount of juice mixture is removed. Removed means subtraction. See, we have done a question before this for evaporation. Same thing here, subtraction. Okay, and replaced with another juice. Okay, so replaced with another mixture. Okay, replaced with another mixture. Now replace means whatever quantity I am taking out, I am replacing it with same quantity. This gives me my final juice mixture. Okay, what happens because of this? This gives me my final juice mixture. Okay, now that this is done, step 2, let's focus on the quantity. Okay, now if you read here, they're asking what fraction of original mixture was replaced. So they're asking the fraction. Okay, so let me say that initially the total mixture was 1 complete fraction. From this I have removed some x fraction and replaced it with the same quantity, which is again x fraction, ended up getting the whole fraction again. Okay, for example, I had 10 liters, I took 2 out and replaced it with 2. So in the end, again I will have 10 liters. Okay, but because the question is asking for fraction, I'm taking the complete fraction, which is 1. From this, x fraction is removed, x fraction is replaced, so added up gives me the complete fraction again. Now comes the factor. So if you see, I can see the percentage of fruit extract, right? Percentage of fruit extract. So I will write percentage fruit extract as my factor. Okay, I'll write percentage fruit extract as my factor. Originally, there is 45%. The one that I am replacing, okay, the one that I am removing, that is also original. So that also has 45% only. See, this I am removing from this. So if this has 45% fruit extract, whatever I am removing also has 45% fruit extract. And I am replacing it with a like inferior product, right, which is your 20% fruit extract. Okay, so the one that I am replacing it with, that has only 20%. Okay, now after mixing, the final is 30%. After mixing, the final is 30%. Table complete. Let's write the equation. 45% times 1 minus 45% times x plus 20% times x is equal to 30% times 1. Okay, again percentage cancels out. I have 45 minus 45x plus 20x is equal to 30. 15 is equal to 25x, x is equal to 3 over 5. That means 3/5 of the solution was replaced and removed. Okay, so again, see, a little bit of replacement happened, correct? Doesn't matter. You just write your table. Okay, you just write your table. Okay, another important point here, if replacement happens more than once and it's a pure replacement, okay, we'll learn that concept in advanced video, wherein I'll teach you another simple method of solving that much faster than this. Okay, however, if replacement happens with an inferior product, okay, your table will work very easily for you. Okay, so I hope you understand. Okay, I hope you understand the concept of mixtures. Okay, I understand that it is difficult for some. I hope this table method, okay, makes it easier for you. Okay, you are able to make the table easily, you are able to think about the problem easily, and then you just have to solve one equation. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and try to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.